Hello, today we are going to talk about completing squares. What exactly you are going to do with completing squares is to change a quadratic from standard form to vertex form. You already know the shortcut that we talked before. Remember that to find the x-coordinate of the vertex, we use the following formula. Let's say we have this quadratic equation. Y is equal to 4x squared minus 16x minus 2. To change it to to vertex form, remember the vertex form has the following general format, that y is equal to a times x minus h squared plus k, where a is the leading coefficient of the standard form, which is 4. H and k are the coordinate of the vertex. If you don't remember what exactly is a vertex, is the following. When you draw the parabola or the quadratic equation, you will get a graph which looks like one of these graphs. Now, the vertex is either the maximum or the minimum of your graph. In the general form, h is the x coordinate and k is the y coordinate of the vertex. It can be shown that the x coordinate of the vertex is given by the formula x sub h, meaning the x coordinate is equal to minus b over 2a. Now, b in above example is minus 16, so it's going to be minus times minus 16 over 2a, which is 2 times 4, which is going to be minus times minus is plus, so it's 16 over 2 times 4 is 8, so it's going to give us 2. So this means that the x-coordinate of the vertex is equal to 2. Now if you look at the example, the leading coefficient is 4, which is positive. Since the leading coefficient is positive, parabola opens upward. So in our case, our parabola looks like the following. And the x-coordinate of this point is given by 2. To find the y-coordinate, we are going to substitute back x equal to 2 in this equation. So we are going to get v sub y is equal to 4 times x squared, which is 2 squared, minus 16 times 2 minus 2. Now 2 squared is 4, 4 times 4 is 16, minus 16 times 2 is 32, minus 2, which is going to give us 16 minus 32 is minus 16, minus 2 is minus 18. So from these two, we are going to get the vertex is at the point 2 and negative 18. Now, knowing these two, we can find the vertex form of our quadratic equation. So it becomes y is equal to a, which is the leading coefficient 4, times x minus h. H is the x-coordinate, which is 2, x minus h, which is x minus 2 squared, plus k. K is minus 18. Minus 18. So this means that this equation is equivalent to this equation. How we know it is if you expand the vertex form, you're going to get back the standard form. But the lesson here is another technique to find the vertex form, which is called completing squares. Now, in completing squares, if you have a quadratic of the form which is the standard form, the process to get the vertex form is a little bit more involved. It's not as easy and simple as the shortcut that I showed previously. How does the completing square works? First, when you're writing the standard form, always start with the highest power to the lowest one. So x squared first, then x, then the constant. The first thing you're going to do is that you're going to put a bracket between the terms that they have the x component or term, which is 4x squared and 16x. The second step is always make sure the leading coefficient of x squared is 1 in the bracket. So I'm going to take 4 out, factor out 4. So I'm going to get 4x squared divided by 4 is x squared. 16 divided, negative 16 divided by 4 is 4, negative 4. So I get 4 times x squared minus 4x minus 2. Now, look inside the bracket, look at the coefficient of term x, which is negative 4. Divide negative 4 by 2, always divide by 2, so you get negative 2. Then square negative 2, so you get negative 2 squared, which is 4. Now inside the bracket, add and subtract 4. So we get x squared minus 4x plus 4 minus 4, and then minus 2. Remember, these two terms, they add up to 0, so we are really doing nothing with the bracket. But now take the first 3 terms, the term that involve the addition. X squared minus 4x plus 4. I can write the first 3 terms as x minus 2 squared. The reason is that if you look at x squared minus 4x plus 4, square root of x squared is x, square root of 4 is 2. Now 2 times 2 is 4 times x is 4x, which is going to give you this middle term. Since you have a negative 1 here, I put a negative here, and this is going to be squared. So x minus 2 squared, which is a complete square. And then here we are going to be left with a negative 4 because we didn't involve it with the first 3 terms, and then minus 2. Now I'm going to expand 4 inside the bracket. I get 4 times x minus 2 squared, and then 4 times negative 4 gives me negative 16, and then a negative 2, which is outside. This gives me 4 times x minus 2 squared, minus 16 minus 2 is minus 18. If you compare this with the previous technique, the shortcut, you can see that we got the same, exactly the same equation in vertex form. This process is called completing squares. The process is more involved and a little bit tricky, just you have to be careful not to make a mistake. Another type of completing squares is when the coefficients are in fraction. So the next example, we are going to consider a quadratic formula in standard form, which is going to produce fraction coefficients. In this example, we have a quadratic which has only 2 terms. In standard form, half x squared plus 4x. We are supposed to find the vertex form, but using completing squares. So again, we write the terms from highest exponent to the lowest one. This quadratic is already in that form, x squared and then x. We are going to take the two terms which are involved with variable x, which is half x squared plus 4x. So we are going to put a bracket between these. And then we have to make sure that the coefficient of x squared is 1. So we factor out half. Now half divided by half gives me 1. Now the question is that what is 4 divided by half? 4 divided by half. Remember 4 is really 4 over 1. So what is 4 over 1 divided by 1 over 2? Remember from elementary school, when you are dividing fraction, you are going to flip the second fraction and then multiply. So I'm going to multiply 4 over 1 and 2 over 1. Now, when you multiply fractions, you multiply numerator divided by product of the denominator. So it's going to be 4 times 2 is 8, divided by 1 times 1 is 1, which is equal to 8. So this becomes x squared plus 8x. Now, I'm going to divide 8 by 2, which is going to be 4, and then square 4. 4 squared is 16. I'm going to add 16 and subtract 16. So I get 1 over 2 x squared plus 8x plus 16 minus 16. Now I'm going to package the three terms. Remember, you always use the plus half b squared. You never use the negative term here. So x squared plus 8x plus 16. Again, x squared plus 8x plus 16. Take the square root of x squared is x. The square root of 16 is 4. Now 2 times 4 is 8 times x is 8x, which is this term. And there is an addition here, so you add here and then square it. So x plus 4 squared. So I'm going to make this one as x plus 4 squared, and there is a negative 16. Now I'm going to distribute 1 over 2 inside the bracket. I get 1 over 2 times x plus 4 squared minus 16 times 1 over 2 is going to give me 8. So this standard form of the quadratic becomes this vertex form using completing squares. In the next example, we have a word problem. We have a volleyball which follows a parabola. The equation of the ball at any moment is given by y equal negative 2x squared plus 10x plus 0.1. X represents the horizontal distance which is traveled by the ball, and y represents the height of the ball. Now, if we look at the leading coefficient, which is negative 2, we can see that the parabola opens downward. So this means our parabola looks like the following. Now, the first part of the question that we are asked to do is to plot this parabola. To do this one, we can either use the table of values, or we can use the shortcut, or we can use the completing squares to find the vertex form of the parabola, and then from the vertex form finding the coordinate of the vertex and then plotting the graph. So we are going to use the completing squares to find the vertex form. So again, the first thing we are going to do is that we are going to put the standard form from increasing exponent to decreasing exponent, which already is given, so we are not going to change anything. Then the second thing we are going to do is that you are going to put a bracket around the first two terms. Since the condition for completing square is leading coefficient to be 1, we are going to factor out negative 2. So we are going to get negative 2. Now, negative 2x squared divided by negative 2 gives us 1, so x squared. 10x divided by negative 2 gives us negative 5x plus 0.1. Now, we are going to divide negative 5 by 2. So negative 5 by 2 is negative 5 over 2. Then we are going to square negative 5 over 2, which is going to give us 25 over 4. Remember, negative 5 times negative 5 is 25. 2 times 2 is 4. So I'm going to add and subtract 25 over 4 inside the bracket. So I'm going to get the following. Now I'm going to take these three and I'm going to use the complete square. Now the square root of x squared is x. The square root of 25 over 4 is 5 over 2. Now 2 times 5 over 2 is going to give me 5. Then multiply 5 by x, we get 5x, which is the middle term. Since it's negative 5x, I'm going to put a negative here. So this becomes x minus 5 over 2 squared. So I get negative 2 times x minus 5 over 2 squared, negative 25 over 4 plus 0.1. Now I'm going to distribute negative 2 inside the bracket. I get negative 2 x minus 5 over 2 is 2.5 squared. Negative 2 times negative 25 over 4 gives me plus 25 over 2, because 2 over 4, 2 is going to cancel and 4 becomes 2, plus 0.1. Now this one I can write as negative 2 x minus 2.5 squared. Now 25 over 2 is 12.5. This one is 12.5. 12.5 plus 0.1 is going to give me 12.6. So our original quadratic equation in standard form becomes negative 2 times x minus 2.5 squared plus 12.6 in vertex form. Now I'm going to go ahead and roughly graph this equation. So this is going to be my x and y coordinate system. To plot this one, I know the vertex here is 2.5 and 12.6. So 2.5, if it's somewhere around here, 2.5, 12.6 is somewhere around here. So my vertex is going to be here. The other thing is that since the leading coefficient is negative 2, we know that the parabola opens downward. Now I'm going to find the y-intercept. If we go back to the standard form, the y-intercept is the constant, which is 0.1. So we can say that this here is the y-intercept. Now we need another point to finish our graph. To find another point, I'm going to look at the vertex. Remember, the x-coordinate of the vertex is going to tell us the equation of the line of symmetry. The equation of the line of symmetry, x is equal to the x-coordinate of the vertex, which is 2.5. So this is our line of symmetry here. The nice thing about line of symmetry is that every point on the parabola is symmetric about this line. So if the y-intercept is here, I will go equal distance to the right of this line, which is going to be here, and it's going to give me the other point. Now I'm going to plot our parabola. So this shows us how the ball is going to move when it leaves and it goes upward. Now the next part of the question is asking what is the maximum height of the ball. The maximum height of the ball is the y-coordinate of the vertex, which is 12.6. So the maximum height of the ball is 12.6 meters. And the last part of the question says when, at what horizontal distance the maximum height is achieved. And that horizontal distance is the x-coordinate of the vertex, which is 2.5. So when the ball is 2.5 horizontally from the initial position of the ball, the maximum height, which is 12.6 meters, is reached. Our last example is another word problem which is about Amir, which he's selling steak sandwiches for $8. Now, when he sells the sandwiches for $8, he sells about 100 sandwiches a day. Now, Amir tries to raise the price to increase his profit. After doing a survey, he concludes that every time he increases the price by 50 cents, he will sell 5 fewer sandwiches. The question is that what is the maximum revenue and what is the price per sandwich at maximum revenue? So again, let's represent R to be revenue. Now we know that the revenue is the number of sandwiches sold times the price per sandwich. We know that without increase, the price per sandwich is $8. Now, let's represent X to be the number of times we increase the price by 50 cents. So, we are going to say, let's at the maximum, X, as we said, is the number of increases, so it's going to be the price per sandwich is going to be 8 plus 0.5 X. Again, if I increase the price once by 0.5, the price is going to be 8 plus 0.5 times 1. If I increase it twice, it's going to be 8 plus 0.5 times 2. This is the price per sandwich, and then we know that without the increase he sells 100 sandwiches, but every time he increases the price he sells 10 fewer sandwiches, or 5 fewer sandwiches. So it's going to be 100 minus 5x. Again, this is number of sandwiches, and this is price per sandwich. If we find the product, this is going to be our revenue. Now this, if you expand it, because if you're going to have x times x, you're going to get x squared, which is going to be a quadratic. The question is that, first, what is the sign of the leading coefficient? You have a 0.5 here, positive, and you have a negative 5 here. So if you multiply, we're going to get a negative leading coefficient. So our quadratic is going to open downward. Since the quadratic opens downward, the vertex is going to be a maximum, which is exactly what the question wants, maximize. Now, to find the coordinate of the vertex, there are two choices we have. Either we can expand this one and then using the completing squares, or we can find the x-intercepts and use the formula, the average of x-intercepts, to find the vertex. We are going to use the last one, which is finding the x-intercepts. Is much easier. So to find the x-intercept, we have to make r equal to 0. Now, to find the x-intercept, we have to solve two linear equations. One of the linear equations we have to solve is 8 plus 0.5 x is equal to 0. From here we get 0.5 x is equal to negative 8. We move this to the right. So x is negative 8 over 0.5, which is going to give us negative 16. The next equation we have to solve is 100 minus 5x is equal to 0. So again, this time I bring negative 5x to the right. I get 5x is equal to 100. So x is equal to 100 over 5, which is equal to 20. So I get two x-intercepts, negative 16 and 20. So the x coordinate of the vertex is 20 minus 16 over 2, which is 4 over 2, which is 2. This means that for maximum revenue, Amir has to increase the price twice. To find the y coordinate of the vertex, I'm going to replace x in the equation for revenue twice, or x equal to 2. So we get that v of r is equal to 8 plus 0.5 times 2 and 100 minus 5 times 2, which is going to give us 0.5 times 2 is going to give me 1. So 8 plus 1 is 9. Now 5 times 2 is 10. 100 minus 10 is 90. Now 9 times 90 is going to give me 810. So this means that the price of one steak sandwich has to be 8 plus 1, which is $9. And the maximum profit is $810.